Hi, welcome to my YouTube channel. My name is Matthew Kimoso. In today's video, we are going to learn how to convert pictorial drawings into orthographic projection. And by the end of this video, you will be able to dimension the end elevation, the plan, and the front elevation. And also to know what to dimension and what not to dimension. Now, I will have this question here so that we can answer it into orthographic. Now we have this question set: convert the pictorial into first angle orthographic, taking front view in the arrow shown. Now, if this is the arrow, this is the block, and I will say this block is this one. Now, in reality, we have this block sitting this way. But when we want to represent these drawings on paper, we can either use isometric projection or oblique. So our main job here is to know where is the front elevation, how do we convert this front elevation to maybe first angle or third angle. We will have the hand, maybe the hand, the front, and the plan. But for this case, we shall answer this question using first angle orthographic. Now, the first thing we need to know is how is the format? How is the format of first angle when you've been given the front elevation in this direction? So when you've been given in this direction, there is a certain format you must follow. Now, let me just expound on first angle. When you have first angle, we have two formats. When this arrow comes from this side, the front elevation will be on this side, and then this is the plan, and then the end elevation. When the arrow of the front elevation is coming on this direction, it changes. This one will be on this side, and then this one. Maybe I will indicate the arrow of front if the front elevation is coming in that direction, and if the front elevation is coming in this direction. So this is the format for any direction, front coming from this side, and this is the format for front coming from this direction. Now, for our case, we have our front elevation coming in this direction. So this direction is indicated here. So this is what we will consume. We will consume this format. So we want to view the elevations. That is the front elevation, the hand elevation, and the plan. Now, let me take out this one because we don't require this format here. So I've known that we require the front elevation, the plan, and the hand elevation. The first thing to consider is know that this drawing has been drawn in pictorials, but on the ground, the drawing itself is orthogonal. The corners is orthogonal. That means all corners meet at angle of 90. All the faces meet at angle of 90. Now I will mark the front elevation using a shade or a different pattern. So let me mark the front because the arrow of the front is coming from this side. This will be our front elevation. So it will take a shape of a rectangle. So let me just mark this as my front elevation. So this one will be my front elevation. This is my front elevation. But remember, in this front elevation, we will have some hidden lines. If you can refer to my second video on this channel, about the broken lines and the center lines, I've clearly shown what is hidden inside here. So we have this corner as a line which runs inside this hole and it is hidden. So we'll have to represent these hidden lines on this surface when we shall be drawing the front elevation. Let me now mark the end elevation. Now if you turn back from front elevation, turn back to this side. That is the end elevation. Now from front to this side will be the front elevation. So front elevation is this side. So it will take the shape which I've marked on a green color, which I've marked on using a green color. So this one will take, so this one will be my end elevation. So if this is my end elevation, so I've gotten the end elevation and the front elevation. So front elevation is this one, end elevation, this one. Now we have the last one, plan. So plan is the same as top view. Top view. So this is my top view. I'll just mark this one using some dots. So remember this surface is the one which is visible on our side. On our eyes, this one is visible. But according to this drawing, we are not able to see the surface running along T70. So this block has made this surface not visible. Now, so this one is visible from the top. This one is very clear. We are able to see this one. So this one will be our plan. So that one will be our plan. Now let us draw this one in first angle. And I will use the simplest method to draw. There is so many ways to come up with this grid so that you can align. We have to align the front elevation with the plan. So it means the length of the front elevation must align with the length of the plan. That is the key point in this drawing. Then the height of the end elevation must align with the height of the end elevation must align with the height of the front elevation. Not unless we have the object with uneven heights. That's where now you will adjust your heights, but it must align. So let us make this grid. So I'll make this grid here. I'll make this grid. So that grid must give us 90. So I'll use this. I will use my protractor to come up with angle 90. So I've given angle 90. So maybe you can extend this side and also extend this side. Now in this drawing you realize you have been given the measurements. We have the measurements of 70 and 50. That is for the case of front elevation. Now we will be using the real measurements. Of course this measurements is in millimeters. This is 50 millimeters, this is 70 millimeters. We want to know where our front is. So this front will be on this side. So maybe I can erase this one so that I can have my space. Now you measure 70. Maybe you can start from this side, coming this way. Now this corner, let it enter into this corner. So I will measure 70 from this side. So I will measure 70. I will measure 70 from this side. So I can duplicate my line inside here. So maybe that is my 70. You will measure your 70 using your scale. then the height is 50. And remember I say the corners are orthogonal, so it means it gives us a line, a corner of 90. So this is 50, and then this is 70. Now remember, this corner is this corner. We are drawing this thing now from this side. We are drawing from right to left, so we are moving towards left. So if I draw this one, I'm drawing this way. So I'll also make this 90. So at the end of 70. So we say it will take a shape of a rectangle. So I will align this. Now that is what is feasible on our surface. Maybe I can have this block here, and you can see this drawing looks this way. This drawing looks this way. So we can see this surface is this surface, and this one is this one, this one is this one. Now because this drawing might be in isometric projection, you see now we are seeing just a small portion of this surface inside, this surface running this way. So we're just seeing a portion, but in real sense, we have the surface. Now, so you can see this. Now we have the hidden lines. You realize on this surface here we have two faces or two surfaces meeting. We have here and this surface. So it makes what we call a corner line. So we have a corner line. That is when two faces meet at an angle of 90. It will give us a corner line, and that line is hidden. So we are not able to see the line from this side. So we will measure the height. We have been given the height here 20. So this is 20. You realize it is uniform 20. So I'll measure 20 from this side up to this point, and then up to this point. So pick, you can measure, or you measure 20 millimeters from your scale rule. Then you give it that way. So this one is a broken line. Maybe I can just have this going broken. So that's a broken line, showing us that there is some lines which are not feasible. Now, I think from this point we have finished on the front elevation. We don't have anything else. Let us go to the plan. Let's go to the plan. Now, at this point, you'll have to separate your front elevation, the front elevation from the plan. So maybe you can give an allowance of 20 millimeters or 20 to 25 millimeters. Then you separate this here. So separating that, we have the plan. Now, when you want to fit the plan, when you want to draw the plan, you realize now our plan on this drawing now is skewed. It is skewed, meaning it has an angle. There is an angle. But when you are dealing with real life, especially if this is the block, assuming it's a building, this building has corners of 90 degrees. So there is no way you can say this one is angle 60, angle 90, because you are dealing with real situations. Now this one is orthogonal, so the surface is orthogonal. Now for you to draw the plan, you view it with respect to front. So it means you come to front, then you can turn this thing this way so that you can see now how is the plan. Because we say we must align the length of the front elevation to the length of the plan. So the plan must align. So this one is 70. Now you realize that we have three surfaces now visible. We have this surface and the inside surface, this one, this surface, and this surface. Now this surface is this surface, and then the one which is inside has an independent surface, but now it will be reflected on your eyes as if it is on the same level with this one. So this one will be pushed to this side because we are dealing with only a surface, not a length going inside or outside. So this one is this. Now I want to draw this one here. So if you like, you will have a measurement of this size, that is 60, because this is uniform, 60. So I will have 60, then we'll have 70. 70 is this one. Now we have 70 by 60. Then we partition this is 20, then 20. So we have 20, this one 20, and this one 20. So I'll do that very fast. So the first thing is to measure. So we know this one must align. Those are the rules of orthographic. So this one must align. Now, along this line now, this is where we have 20, 20, 20. So you measure 60. So you measure 60. So you measure 60. So I'll take 60. And then I will join this one to this. And then this one to that point. Now we want to give now the surfaces. How many surfaces are available? We have 1, 2, and 3. So remember this. This corner here is this corner. This corner 1 here is this corner. This corner is this corner, and the other ones are now clear. This one and this one. So this one is this one. This one is this one. Now we need the surface. So you can start coming down. You come down 20. So you measure 20 here. Then you mark 20. So this is 20. This one is 20. Then the remaining one is, so coming from this side is 20. Then the balance is 20. So there's no need. I'll just measure 20. Then I'll mark. So I have my plan. So that is the top view. That is what you will have to obtain. That is your top view. So when we move to the end elevation, the end elevation now is you turn back from this plan, then you come to your other side. So we have this. So we have this as the front. So you turn back. So we shall be turning back. So you look at this way, then you turn back this way. So this is our shape. So that is our shape. So you will go and view. So you will come and view this one on this side. So we'll have that shape. So we said the front elevation, the height of the front elevation must align to the end elevation, the height of the end elevation. So we'll do the separation again. So we'll apply. We shall show the separation. You can measure 20 here. Then you produce perpendicular line up here. Then after getting that, you know now that our height is 50. So you measure 50, or you can just simply align this one because it is aligning. So you can measure this up to somewhere there. Then now you realize now we are drawing, this one is now changing. We are drawing from left going to the right, not the vice versa. We are drawing from this side to this side because we are feeling, then we draw. Now from this side you are drawing coming from this way, but it's simply taking this and then you place. Take this one, place it there. So we shall draw from this side going this way. So I'll measure 60. So measure 60. So that is my 60. That is my 60. Maybe I can join so that I can make that shape. So we have, assuming that we don't have this, so we've got our drawing. Now we want to cut this surface, this one. So remember, we shall not see any line. These lines going this way are not visible because they are in a corner. They are inside a corner. So as you can look this way, we are just able to see these lines, but not this span. This span is not visible. The only place you will see this length is on the plan and maybe on the front elevation. So I'll just give my solution. So you measure 20, then measure 20, then you drop 20. So, and you realize that hidden line now is now available, the height is available on the front elevation. So we can just transfer this to this end, and then we mark 20, you drop, then you mark 20, you drop. Now maybe you can use construction lines so that you cannot, so that you can't make your work dirty. So that is it. That is my front elevation. So if you can check the colors, this one was the front elevation. Now we have the shape, but the broken lines are coming up due to hidden lines. So we have this line hidden on this surface, and this line is also opposite to this line running on this way, which we are not able to see now. So that is it. Then we have this shape which looks like a U. So this one is this one. So the color itself is what is end elevation. And then the plan, we have this 1, 2, and then 3. So we have 3 surfaces, and that is it. Now we can dimension it very fast. Now you realize that in this drawing we have some lines which shares the same length. So we will not be able to dimension or repeat ourselves. We will not repeat the dimensions on the same drawings. So we will have this 70. Maybe I will just have this here. I will dimension it here. So you will make sure the dimension line is parallel to what you are dimensioning. So that is it, 70. Now you realize I've given 70 and this is also 70. So there is no way I am going to repeat myself. Now I will not dimension here because I've dimensioned this way. Now what is remaining is, if I dimension here up to here, I will have to dimension 20, 20, 20. And you realize that always this is like height. This is like height, but we know it's length from the plan. So it is this length. And we know that this length is the same as the length of the end elevation. So this length is the same as this length. So I'll just make one dimension. So I will make 3. I will make for this. Then I will do an overall here. So that this is 20, this is 20, and the overall is 60. You can subtract, then you get the remaining. So maybe I will do here 20, 20, 20, 20. So on this side, 20, 20. So because I said I don't want repetition, I'll just mark this one here, and I just stamp this, just give this dimension as 60. So by showing this is 60, I have shown that this side is 20, this side is 20, and the other one is 20. The overall you subtract, you get the other one. Now what we are remaining is, we are remaining with the height of this and the overall height of this 50. So 50, 50, and then 50. So I'll just do an overall. So you ensure that the overall height is not far. The overall height is away from the smaller height. So this one is 20, and then this one is 50. In that case now I have shown the dimensions, and that is how you convert the pictorial drawing into orthographic projection. Specifically, we are doing the first angle. So up to that end, we will end there. Join me in my next video to understand more about orthographic. Bye.